All right, welcome. We're handling question 20. The figure below consists of a semicircle and an isosceles triangle. So, if AB is 35 centimeters, so we are having that AB is 35 centimeters, and that the diameter of the circle, that would be DB, is 42 centimeters. Find the total area of the shaded region. So we are having two isosceles triangle basically. We are having the triangle ABD. It's an isosceles triangle. And we're also having the triangle BCD. It's an isosceles triangle. Those are two isosceles triangles right there. Now we have the inner part of the semicircle shaded, and then the other triangle, the other isosceles triangle, that is a triangle ABD, is actually shaded. And remember, BCD is unshaded. And the question is asking us to find the area of the shaded region. That would be this triangle right here and these other sides of the semicircle. So we're going to start by finding the area of the triangle ABD, alright? So we're going to start by finding the area of the triangle ABD. And we know that area of a triangle is usually given by a half into base times height. All of us agree with that, isn't it? So basically, our triangle ABD will look something like this. Remember, it's an isosceles triangle. And we're having A there, B and D here. And it is, of course, shaded. We are having that the line BD will be what? 42 centimeters. And that the line AB will be what? 35 centimeters. So basically, if we are able to drop a perpendicular from A to the line BD, it will bisect the line BD right at the center, katikati, right at the middle, right? Such that we are going to have, let us have this point O here, so that we're going to have BO being 21 centimeters and of course OD being 21 centimeters as well. So basically, now that we have BA as 35 and BO as 21, we can easily find the height of this triangle ABD using Pythagoras Theorem. So by Pythagoras Theorem, we are going to find that the height will be given by the square root of the hypotenuse minus the base squared. Alright, so that will be the square root of 35 squared minus 21 squared. And this one will give us, and this here will give us 28 centimeters. So basically the height of this triangle ABD is 28 centimeters. Just a minute. Good. Now, for us to find its area, we're just going to have to take A equals to a half times our base, which we've established to be 42 centimeters, times our height, which we have as 28 centimeters. And this should give us our area. Now, note this will give us, in a moment, this will give us area of 588 squared centimeters. So this will be the area of the triangle ABD. But note, this is not the only area in this figure that is shaded. We also have these two sides of the semicircle shaded. So for us to find the area of these other shaded regions within the semicircle, we'll find the area of this isosceles triangle, that is the isosceles triangle BCD, and we also find the area of the semicircle and get the difference of that to get the area of the other part of the semicircle. So basically, the area of a semicircle is given by, so area of a semicircle is given by a half pi r squared. All right, because it's a semicircle, so it will be a half times 22 all over 7 times r squared. The radius of this semicircle will be a half of the line BD, which happens to be 42 centimeters. So the half of line BD will be 21 centimeters. So but that will be basically 21 times 21. All right. So this will generally give us in a moment 5 times 22 all over 7 times 21 squared. This will give us 693 squared centimeters. So this is the area of the whole semicircle. This is the area of the whole semicircle. That is a semicircle BDCD right there, right? But we're supposed to find the area of the shaded region on the sides of the semicircle. So for us to do that, we're going to first of all we're going to have to find the area of the isosceles triangle that is within the semicircle, and then subtract it from the area of the whole semicircle for us to get the area of the shaded region. So basically, the area of the isosceles triangle, we've already established that the formula for finding the area of a triangle, all right, is given by a half base times height. All right, so that will basically be a half times the base of this triangle. As you can already see from here, the base will be what? The base will be 42. All right, so our base will be 42 times our height. Now, very special, the height of this triangle will be but the radius of the whole semicircle. All right, so because the radius cuts across and goes up to the point C from the center, therefore the height of the triangle will be the radius, which happens to be 21 centimeters. All right, so the area of the triangle therefore becomes 0.5 times 42 times 21, which will be 441 squared centimeters. So for us to find the area of the shaded regions on the parts of the semicircle, we'll basically take the difference between the semicircle and this triangle, and so the area of the shaded region, will be equal to 693 squared centimeters minus 441 squared centimeters, which will basically give us, all right, 693 minus that, which will give us 252 squared centimeters. So for us to get the total area of shaded region, then we'll add 588 square centimeters to what? 252 square centimeters. So total area of shaded region will be equal to 588 squared centimeters plus 252 squared centimeters to give us that will be 840 squared centimeters. So we can also have it as 840 squared centimeters right there. End of the question.